Good morning, ma'am. I am Hema from Computer Science and Engineering Department. Now, my topic is execution of a complete instruction. Now, I am going to discuss about introduction of the complete instruction, overview, instruction cycle, instruction register, executing an instruction, cache memory impact, and then conclusion. Introduction to instruction execution. The execution of instructions is fundamental to computer operation. This process involves fetching, decoding, executing, and storing results. Understanding this flow is essential for grasping computer architecture. Instruction is a command which is given by the user to computer. Execution is the process by which a computer performs instruction. Instruction execution means a program to be executed by a processor consists of a set of instructions stored in memory. Overview of computer architecture. Computer architecture defines the structure and behavior of a computer science. It encompasses the CPU, memory, and input or output systems. Each component plays a critical role in the instruction execution cycle. Here we can see the computer architecture. Input device is connected to the CPU. In the CPU we have two units, control unit and the another one is arithmetic logical unit. And there are two memories are there, secondary memory and the main memory. Main memory is also called as RAM, means read access memory. And this in the CPU output device is connected. Through the input device, the user give the instruction to the CPU. It will process and execute the program to the output devices. Instruction cycle. The instruction cycle consists of several stages: fetch, decode, execute, and store. This cycle is repeated for each instruction in a program. Efficient execution of the instruction cycle is crucial for performance. Here we can see in the CPU, the instruction cycle will start. First, it will enter into the fetch stage, decode stage, and execute stage, and the last one is store stage. In the store stage, it will check for the interrupt. If there is any interrupt, it will go to the service interrupt. Otherwise, it will go to the instruction cycle and the process will continue. Fetch stage. During the fetch stage, the CPU retrieves the instruction from memory. The program counter PC indicates the address of the next instruction. After fetching, the PC is updated to point to the subsequent instruction. Here, in the fetch stage, it retrieves an instruction from the main memory and determine what the instruction is in the decode stage and carry out the instruction in the execute stage. Now, instruction register. The fetched instruction is loaded into the instruction register IR. The instruction register holds the current instruction that is being executed. This allows the CPU to decode and execute the instruction effectively. Here we can see in the CPU, the instruction fetch is start, and then it will go to the address register and it will go to the memory control, and the last one it go to the instruction register and then arithmetical logic unit. Decode stage. The decode stage interprets the binary representation of the instruction. The control unit translates the instruction into control signals. Decoding determines the operation and the operands involved. Here we can see the fetch stage. Instructions are stored in a binary representation. See, we can see all binary numbers are there, 0 and 1. And it has some register numbers. Here we can see the read register 1, read register 2, write register. So collection of registers known as a register file. So it will register and the data will go to the arithmetical logical unit stage. Operand fetching. Operands may be located in registers, memory, or immediate values. The CPU fetches the operands required for the execution of the instruction. This step is critical for preparing the data the instruction will manipulate. Here operands are stored in the form of registers, memory, or the immediate values. Here we can see the main memory. Software program is in the main memory. It will fetch the software program into the decode and it will execute and then it move to the main memory again. Execute stage. Execute stage is where the actual operation defined by the instruction occurs. Arithmetic logic units perform mathematical and logical operations. The results of this execution are typically temporary until stored. Store stage. After execution, results must be stored back into memory or registers. This stage ensures that the output of an instruction is saved for future use. The destination for the results is determined during the decode phase. In the execution stage, the results are temporarily stored. In the store stage, it will store the output in the instruction for the future use. Executing an instruction. Fetch the contents of the memory location pointed to by the PC. The contents of these location are loaded into the IR fetch phase. IR to PC. Assuming that the memory is byte addressable, increment the contents of the PC by 4. Here we can see the PC is incremented by the value of 4. Carry out the action specified by the instruction in the IR. This is the execution phase. Instruction execution proceeds as follows. Here we can see the some steps for the instruction execution. Step 1. The instruction fetch operation is initiated by loading contents of PC into MAR and sending a read request to memory. The select signal is set to select 4, which causes the MUX to select constant 4. This value is added to operand at input B, PC's content, and the result is stored in Z. Step 2. Updated value in Z is moved to PC. Step 3. Fetched instruction is moved into MDR and then to IR, instruction register. Step 4. Contents of register 3 are loaded into MAR and a memory read signal is issued. Step 5. Contents of the register 1 are transferred to Y to prepare for addition. Step 6. When read operation is completed, memory operand is available in MDR and the addition is performed. Step 7. Sum is stored in Z, then transferred to R1. The end signal causes a new instruction fetch cycle to begin by returning to step 1. Cache memory impact. Cache memory significantly influences instruction execution speed. It stores frequently accessed instructions and data for quick retrieval. Reducing fetch times from main memory accelerates the instruction cycle. Here the cache memory is present in between CPU and the main memory. The transfer between a CPU and a cache is said to be word transfer, while in the transfer between the cache and main memory it is called block transfer. Cache memory is the fastest memory in the computer. Future trends in instruction execution. Emerging technologies like quantum computing may redefine instruction execution. Advances in parallel processing continue to shape CPU architecture. Future systems will likely focus on energy efficiency and processing speed. Summary of key concepts. Execution of instructions involves a systematic cycle of fetching, decoding, and executing. Each stage is crucial for the correct operation of a computer system. Understanding these concepts is essential for both hardware and software development. Here we can see the instruction cycle. First it will fetch the instruction and then decode the instruction, and it will read the address from the memory and execute the instruction, and again it will move to the fetching stage. This is called the instruction cycle. So understanding the concept of executing the instruction is essential for both hardware and software development. This is all about the execution of the instruction. Thank you. Hope you like it.